All right, so in this video, we're going to go through sample question 89 from the Society of Actuaries ExamP list of sample questions. Question reads, the future lifetimes in months of two components of a machine have the following joint density function, given here. Determine which of the following represents the probability that both components are still functioning 20 months from now. Now, we don't actually need to calculate the probability, we just need to figure out which one of these can help us determine the probability. So nothing to actually compute. This is actually a good question for reviewing multivariate distributions. Right, so we're given this joint density function and we need to calculate a probability. When you're dealing with these multivariate distributions, a lot of times drawing a picture will help. So let's do that. Okay, I know this will be on some graph as so. Here's my y-axis, there's my x-axis, and let's see. I need to deal with figuring out what the actual domain of my function is, right? Because I have this thing here, but how do I translate this to this? Well, I have three inequalities to deal with. So the first inequality is 0 greater than x, or sorry, x greater than 0, right? That's the first one. And that's just represented by any value to the right of the y-axis. The second one is here, x, which is less than 50 minus y, which I think is more helpful in terms of y, right? In terms of x. So I will move some stuff around, and I'll add the y to both sides, subtract the x, so y is less than 50 plus x. And that's represented by this following line here. From 50 to 50 here. I draw that line here. And our last inequality is 50 minus y is less than 50. Where I can just get it as y is, bring it to this side, greater than 0. So y is greater than 0. All right, which is just obviously represented by anything above the x-axis here. So I have this graph, and all the possibilities, right, exist within this triangle, right? That's our entire domain. We need to figure out the following. Determine the probability that both components still function 20 months from now. Okay, so the first component, right, we want to see it above, let's say this is 20 here. And the second component, that's 20 here. Obviously not drawn to scale. This is the line y equals 50 minus x. Okay, and the thing we're concerned with is this shaded region, right? The area of this shaded region divided by, the area of this entire triangle is going to be our probability. Now, we don't actually need to calculate the probability. What we do need to figure out is the bounds. So let's look at the actual functions it gives us. All of these are dy then dx. So what that tells me is these boundaries here are for our y values. These boundaries here are for the x. So what are all the possible values for y? Well, my y can go from 20 all the way to whatever this number is, 50 minus x. So I know that my the first integral, my innermost integral, will go from 20 all the way to 50 minus x. And that already eliminates answer choice E, answer choice C, and answer choice A, leaves us with B and D. Okay, my next integral, right, once that's already been computed, I have to figure out for x. My lower bound is 20. My upper bound, you'd think it's just 50 minus x as well. However, we need to account for the fact that we've already computed y. So substituting in that value 20, we get the upper bound is 30, right? 50 minus 20 is 30. So we're left with answer choice B. All right, so overall, pretty simple problem. When you're trying to figure out the probability with these multivariate distributions, it always tends to help to draw a picture, right? Draw a graph, shade in the region that you're trying to look for. What that'll do is, when you're trying to use a density function to find the probability you're integrating, what this allows you to do is to help you find the bounds of your integrals, right? And if this question had asked for the actual probability, you would actually just do this integration out, right? You would compute this. If there are any questions, throw it down in the comments. I'll answer to the best of my abilities. If this video helped you out, subscribe, hit the like button. That definitely helps me out. But other than that, thanks for watching, and I hope this helps.